Okay, this is create a table. So ponder this. Is the current periodic table the only way to organize the elements? Why or why not? And so we've kind of bounced around this idea. The periodic table is a model. And there's a reason why it's called periodic. And I'll get to that later. So when you think about it, in 1860, Dmitri Mendeleev was looking for a way to organize the elements known at that time. And you went through an activity in class where you mimicked what he did. And so he was looking for a way to organize it and make it easier to remember the elements and to understand their chemical behavior. So he started placing them in groups based on their similarity of properties. And if you look at ours is pretty colorful on the wall. But those colors actually represent something. And we're going to learn all about what they represent. So more about Dmitri Mendeleev. First, I don't want you to get tangled up on his name. There's multiple ways of spelling it because he is Russian and the Russian alphabet does not combine with ours real well. So, the gist of it, he noticed that there were patterns in the properties of metals. So here I have tin, sodium, magnesium. They're all shiny and soft. And their visual representation is really not a reliable characteristic for sorting the groups. So we've got to look deeper into them. We got to look at the properties of them, the physical and chemical properties. And so if you think on this, many elements are actually shiny, silvery solids at room temperature. Both oxygen and neon are colorless gases. They are not enough similar in properties that they're in the same group. In fact, they're in different groups. And so Mendeleev really focused on reactivities, the formulas of the chemical compounds that form where the element combines, and atomic mass. And that's kind of what they say is his image of the periodic table. Stop! Dmitri Mendeleev was not the only one working on the problem. He was just the first one to publish. He was the first one to publish something that was logical and others could work off and verify. So his periodic table worked. And it worked so well that he could predict missing elements and unknown elements and their properties. But that's why we know him, because he's the first one who did it. So to give you a little fact check here. Here's Lavoisier. He compiled a list of 23 elements. He is our father of chemistry, and he did lose his head during the French Revolution. But notice we've grown. We now have 118 elements. Dobriner placed them in groups of 3. He used math and their chemical properties to group them. John Newlands, he grouped them in octaves, which is interesting because when we talk about octet, which is 8 valence electrons. And then you have Mendeleev, who did his group, and people liked his publication of what he did. So reactivity, that's a property that describes how easily an element will combine with another substance to form a new compound. Highly reactive means that it combines rapidly with other substances. And so some things you might think about is explosion, smoke, flash of light. All that can be sign of a quick reaction. And you can look up sodium and water. That's a good one to see the reaction. So if you notice that lithium, sodium, potassium, rubidium, francium reacted in water violently. And also notice that beryllium, magnesium, calcium, strontium, barium, and radium also react in the presence of water. What would you conclude? History connection. Ancient civilizations discovered and used 7 metals: gold, copper, silver, lead, tin, iron, and mercury. These 7 metals are called the metals of antiquity. They discovered these elements and discovered because they're less reactive than other elements, therefore more likely to be found in pure forms. So because they were less reactive, they were found in pure forms, and that's why they're noted. Formulas and compounds. Mendeleev noted which elements combine with each other. He also paid attention to the ratios in which they combined at. So I ask you to look at this. What trends do you see? Place these elements in groups. Which elements belong together? So we talked about atomic mass, and that's how he arranged it at the time. And each element is made up of different kinds of atom. We'll study those soon. All atoms of the same element have relatively the same mass. The mass of an atom is called atomic mass and is measured in atomic mass units, or AMU. You can place the elements in order of their masses. However, there's a catch, and I've already revealed this for the activity, because it doesn't work all the way through. And simply sorting them by atomic masses does not group them. You have to also group them by their properties, as you saw in your card activity. So periodic, what does it mean? Why did we end up calling it the periodic table? And why does it look like that? So after looking at those properties, he was able to group them. He was also able to leave gaps and predict unknown elements and their properties. At the time, he only knew of 63 elements. We now have 118. Elements in the columns have similar properties and reactivities. They tend to form compounds with other elements in similar ratios. There is a periodic pattern that emerges. Bum, bum, bum. And those are your groups broken down, and we'll talk about those also in detail. Big idea! Elements are arranged on the periodic table based on their similarities in their chemical and physical properties. Boom! Huge idea there. So they're grouped based on their similarities in their chemical and physical properties. Da la 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 la! Those are all periodic tables.